students? You can hear me? Am I audible, students? Please write yes or no. Yes, ma'am. Okay. Okay. So we have done the numerical. Okay. So now we will see the differences between your slow sand filter and rapid sand filter. Okay, on the basis of different items. Okay, on the basis of different items, your rapid gravity filters and slow sand filters are made comparison. So let us see. Uh, See, they are compared according to their pre-treatment requirements, base material, filter sand. Okay, so there are many. You see, under drainage system, size of each unit, rate of filtration. Okay, so it's a vast table. There are almost, I guess, 18 differences. Okay, 18 differences are there. So what you do, these differences, no need to write 18 differences. The points which are already marked with pen, you can see, yes, like 1, 2, 3. So I have marked the easy points, okay. So, and easy and important points actually. So you write those points on your copy, okay. Around around 10 points if you write, then it's fine. Okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 10 points if you write down in your copy, then it's fine. And in question, sorry, in exam, it might not come like this, that compare slow sand filter and rapid gravity filters. Okay, but also it sometimes it might come like differentiate between slow sand and rapid gravity filters on the basis of base material. Okay, like that the items will be given to you. Clear? So for that, like this one, on the basis of base material, on the basis of filter sand. Okay, so the items, it might be already mentioned to you. So for that you need to know the each and every the differences. Okay, based on its items. So try to remember 10 points which I have already marked. Okay, so and you write down in your copy here. So, so you see, these differences are very easy. I don't think I need to go through each and every line. Like this, you see base material. You see the gravel base supports from the sand. It varies from 3 to 65 millimeter in size and 30 to 75 centimeter in depth. But here in rapid gravity filters, the sand bag, okay, the this varies from, okay, 3 to 40 mm in size and depth is your 60 to 90. Okay, so like this, every differences are given very nicely. You read one by one and you write down in your copy. Clear? So I won't be going through each and every line of this here. But see, this is the difference. This difference is based on some of the items it is already mentioned. But if in any interview, or if any somebody in FIVA, if it is asked that you need to differentiate between slow sand and rapid gravity filters, if it is asked like that, then no need to differentiate them based on their items. Okay, you have to differentiate it, like I have already told, what is the major difference between slow sand and rapid gravity filters, that you need to first tell. Okay, Then in slow sand filter, the rate of filtration is slow, and rapid gravity, the rate of filtration is, it is rapid. Then DAW slow sand filter gives more accurate results. Then also you rapid gravity filters are used because of what, it is cost effective. So all these things you need to say, okay. And it is slow sand filters are used in small treatment plants, and rapid gravities are used in big treatment plants and public supplies. Okay, so like this, all these things you need to say. So write it down in your copy. Okay, let us see the next one. So this is up to here. It is a filtration part is finished. Okay, this is the filtration part is finished. So let's move to the next treatment. Okay, so after your your filtration is done. Okay, after filtration is done, as we already we have mentioned that there are slow sand and rapid gravity filters, and nowadays people are using the rapid gravity filters for its for because it is more cost effective, and the rate of filtration is also very high. So but your rapid gravity filters, it doesn't give you accurate results. Not accurate means, that means it doesn't give you much killing of bacteria. Okay, some things, some bacteria are already left in that, left while while you are filtering your water through rapid gravity filters. But then we already discussed that since the filtration is not only the last step of the last treatment step. Okay, after that more steps are already are also there. So we need to worry, and we can transfer that water, that after filtration, that water, it is being transferred to the next treatment unit, that is your disinfection or sterilization. Okay, disinfection and sterilization, it is done after your filtrations. And what is done here, the filtered water that you have filtered by your rapid gravity filters, or whether it is close and filters. Okay, so after filtration again, that water, it might contain, okay, it might contain some more harmful, contain some harmful disease causing bacteria. Okay, so the bacteria which the pathogenic bacteria also, you can say that disease causing bacteria, those might be, it might again be present in that water. So in order to kill these bacteria and to make this water safe, and then to supply to the public. Okay, so what is done after filtration, it is done that some chemicals are added. Okay, some chemicals are added to the water for killing these bacteria or disease causing bacteria, you can say, by adding some chemicals, and these chemicals, these are known as your disinfectants. Okay, these are known as disinfectants, and the whole process of adding the chemicals to the water for killing of bacteria is known as what? Disinfection or sterilization. Same thing. Okay, disinfection or sterilization is the same thing. Suppose you see, I'm telling you, I'm giving you one example. Okay, I'm giving you one example. You tell me, any one of you. Suppose I'm giving you two glasses of water. Okay, I am giving you two glasses of water, and in one glass, okay, there is turbidity, color, odor. Okay, everything is there. All the suspended impurities are present in that, in sample one glass of water. Okay, and that is also, it is crossing the permissible limits. Okay, and in the other glass of water, in the other glass of water, there is only one single bacteria or organism present in it. Okay, so which, if I tell you to drink the any one of the water, so what, which one you will drink? Any one of you, did you get my question, what I am asking? Okay, if two glasses of water is given to you, and in one glass, in that glass, all kinds of suspended impurities are present, turbidity, then whatever you have studied. Okay, so all kinds of these are present in that glass of water, and that is also beyond the permissible limits. Okay, and in the other glass, a single a single bacteria it is present. So if I give you to drink any one of the water glass, then which one will you prefer to drink, and why? Can any one of you please answer me about this question? This is a very interesting question actually. Any one of you? You can either write it in the chat box. If you don't want to speak, that's fine. Sample number two. Sample number two, Hoketo. That means, can you please speak, Hoketo?
Yes, ma'am.
Yeah. Sample number two means which one? The one that is having only one single organism.
Yeah, yeah.
Okay. Can you tell me why? Just your
Uh,
what you think. Why you prefer to drink that water, not the sample one?
because simple one is I think like more harmful things than one.
Okay.
Like it
Okay.
is like bacteria, more turbidity. So like it is all mixtures of infectants. So that's why.
Okay. No, no. There is in sample one there is no bacteria. Okay, bacteria is not present, but in the sample two only the bacteria is present. Okay, sample one, every suspended impurities that you have studied in your this physical characteristics and chemical characteristics. The turbidity. Then what was else was there? That odor. Okay, so all these things are there. Okay, so and that is also beyond your permissible limits. pH is high. Okay, everything is high there. So you told that you will prefer to drink sample number two. Okay, okay, fine, thank you. And another student, anyone who else who have to say anything? I just want to know. Don't be scared to say. Just say. Anyone else? You want to share your idea? Okay.
Ma'am,
Yeah.
the one containing bacteria will
Okay.
be
Why?
because the sample number one it contains odor and taste, so I think it won't be possible to drink the water which is like bad in smell and then bad in taste, and then case of sample number two, then the bacteria can be good for health also.
Okay. Okay. I got it. I got it. Okay. Thank you. You also. Actually, it is interesting question. Okay, it looks like that if you drink the sample number two, then it might not cause harm to you. Okay, but the thing is that it is just the reverse. Okay, it is not like if you drink the sample number two, this will cause more harm to you. Okay, so I'm telling you the reason. Okay, see, uh, this sample number one, it has your turbidity. Yes, you can see that the water, it is turbid, it is not clear. You are getting odor also. Then there is alkalinity, everything is there. Okay, pH is high. Okay, but you remember always one thing, that one single bacteria, okay, one single bacteria, if it goes to your stomach, okay, so it will upset your stomach within 2 or 3 hours. Okay, I am telling you, I am giving you the glass of only one glass of water to drink. Okay, no, I'm not telling you to drink those samples continuously, today also, then after day after tomorrow also, then again, I'm not telling you to continue to drink that water. but I'm only giving you one sample of water, and you drink only at one time. Okay, means only that glass of one water only you need to drink. Okay, so you see, when two samples are there, and in one sample, everything is there, turbidity and beyond its permissible limit. If you drink that sample number one, okay, but then also it will not cause harm to you. Though it's permissible, it is crossing the permissible limits, but then also, if you drink only one glass of water, that will not cause harm to you. Like, if one single bacteria or one single organism, it is going to your disease causing bacteria, it is going to your stomach, it can upset your stomach within 2 hours or 1 hour. Okay, or within a day, it will cause upset to your stomach. Okay, so see, so you can see from this that the disease causing bacteria are so much harmful. Okay, it is very harmful than your carbid water or your other water or alkalinity water. Okay, it is much more harmful than your that water. So disinfection is very much, it is a very necessary step after filtration. When water is given to supplied to armies. Okay, when water is supplied to armies, what it is done there, no, the whole process, it is not possible, there is no time to give all the treatments. Okay, it is not possible to give like plain sedimentation, you have to do screening, you have to do there is no time. So what is done there, first filtration is done, and after filtration directly disinfection is done. Okay, disinfection, after doing disinfection, that water it is directly supplied. Okay, you can drink that water, so you can see how much of disinfection it is important. Okay, the disinfection, what is disinfection? This disinfection means adding some chemicals. Okay, so that chemical, it is most commonly used is your chlorine. Okay, I know you have heard of adding chlorine to water. When chlorine is being added to the water, so that process, the most commonly used is chlorine, and chlorine, it removes most of the bacteria. Okay, you can say 99% bacteria are removed by chlorine. Okay, so that's why I asked you that question, that if one sample it is having one harmful organism, and the other one, all targets and colors and everything is present, so which one will you drink? So your answer should be, you have to drink the sample number one, that consists of turbidities, colors or minerals or all these things. Okay, but not that glass of water containing that harmful organism. Okay, so disinfection, now I have already told you that chlorine is the most commonly used disinfectant while treating public supplies. Okay, so there are some methods by which you can do disinfection, some minor methods you can say. So these are the things you see, these are the minor methods. One is like, you can boil the water. Okay, if you boil the water, so for a long time, so the bacteria, it will get killed. Obviously, no doubt the bacteria will get killed when you boil the water, but it cannot take care of the future, possible contaminants. Means you cannot say that in future also these bacteria will not be, uh, again it will disinfect. Okay, only for that time when you boil, that for that time your bacteria gets killed. Okay, and also, for treating a huge public water supplies, boiling you cannot do. Obviously, boiling of water you cannot do. And boiling of water, it can only be used to treat in your home. Okay, in your home, when two three peoples, four peoples, they drink water, they can boil it and they can disinfect by boiling the water. Okay, but it is not used for your huge amount of public water supplies. Okay, so this you see here, Next is your treatment with excess lime. Treatment with excess lime, yes, lime also, it reduces the, it kills the bacteria. So but you have to add excess of lime, okay, because lime we already know that it, reduces the hardness of water, okay, it reduces the hardness of water. But when you add excess lime, so what will happen, your 99 to 100% of your bacteria, it will get removed, okay. But what will happen when you add excess lime, okay, what will it, since lime, it will increase the pH value, okay. When you add excess lime to the water, it will increase the pH value, and when pH value is increased, what will happen, it will make the water extremely alkaline, okay. So when it becomes alkaline, so that alkalinity, okay, it is very much, found to be, we can say, it can be found to be detrimental for the bacteria to survive, okay. The bacteria cannot survive in alkalinity water, okay. So that kills the bacteria, okay. That that alkalinity water, it kills the bacteria, about, you can say, up to 100%, okay. If excess lime is used, then 100% bacteria are removed. But what about the taste, okay, the taste is already there, the lime taste will be there if you add excess of lime. So that should also be removed before supplying to the public. So one process is there, the name is recarbonation. So recarbonation step is, process is done to remove the lime removal, okay. For the taste of the lime, it should be removed before supplying to the public. So recarbonation is done for the removal of lime. Okay, so like this, many steps are there. You see, treatment with ozone, then treatment with iodine and bromine, treatment with UV rays, treatment with potassium permanganate, and treatment with silver, called electrocatadine process. Okay, so this processes, 7 processes. Just remember the names. The names you remember, and if 3 of them you can remember, then it's fine, okay. Boiling of water, treatment with excess lime, and treatment with ozone also you can remember, or any three you try to remember. Clear? Any three you try to remember. Okay, so let me directly go to chlorination. Okay, let me directly go to chlorination part. So chlorination, from the name itself, you have got to know that the adding of chlorine to water, it is known as your chlorination process. Then let me see what you can write from your doses of chlorine. Okay, so you can write one line. The doses of chlorine, you see how much dose it should be given to the, I mean, doses of chlorine should be added to the water. You can read these lines, okay. In general, most of the waters are satisfactorily disinfected if the free chlorine residual is about 0.2 milligram per liter 10 minutes after the chlorine is applied. Okay. A larger chlorine residual may cause bad taste, whereas a smaller residual may not be relied upon. Okay. So optimum dose is about the dose of The dose which leaves a residual of about 0.2 is then selected. Okay, so dose is not written here. Okay, no need then this lines. Midpoint. Okay, no need about the dose. Okay, so this one, just the names you can see that in which forms, okay, what are the various forms of chlorine that is applied. Okay, what are the various forms in which chlorines can be applied? So number one, you see in the form of liquid chlorine or as chlorine gas. Number two, in the form of hypochlorites or bleaching powder. Okay, bleaching powder everyone has heard. Then number three, in the form of chlorine tablets. Number four, in the form of chloramines. That is a mixture of ammonia and chlorine. Ammonia and chlorine mixture is known as chloramines. Okay. Then number five is your in the form of chlorine dioxide. So you just remember the names. Okay, no need to go in brief. Just remember the which are the various forms in which chlorines can be applied. Okay. Next. Okay. So this one is important. Um, types of chlorination. Types of chlorination and certain important definitions. So this one is important. So what are the types of chlorination you see? Plain chlorination, pre-chlorination, post-chlorination, double chlorination, breakpoint chlorination, superchlorination, then dechlorination. Okay, you have to remember this all the types of chlorination. Then let us see what is plain chlorination. Okay, what is plain chlorination? Let us see. This term is used to indicate that only the chlorine treatment and no other treatment has been given to the raw water. Did you understand what it is said here? That when no other treatment, that means no screening, no sedimentation aided with coagulation. Okay, so nothing, no what we have done then. So it is no other treatments are done. Only your chlorination is done. That means only in that water after only in that water only the chlorine is added to that water. Okay, so when only chlorine is treatment is given and no other treatment is been given to that water, it is known as your plain chlorination. Okay, so it is what it is written here again, let us see. So under plain chlorination, therefore, raw water is fed into the distribution system after giving chlorine treatment only. This helps in removing bacteria, organic matter, and color from the raw water. Okay, so it removes the bacteria also, organic matter, and color from the raw water. So this technique may be used for treating relatively clearer waters. Okay, so this technique is used when turbidities are less than 20 to 30 milligram per liter, okay, obtained from lakes, reservoirs, deep tubules, etc. Then it may also be used during emergencies when full-fledged treatment cannot be given, such as for supplying water to army troops during war times. Okay, so this one, as I already said, okay, so when water needs to be supplied to army troops during war times, so during that, full of every treatment cannot be given, so the treatment which is given is only adding chlorine to the water. Okay, so you need to know the dose. So the used quantity of chlorine required for plain chlorination is about 0.5 to 0.5 milligram per liter or more. Okay, next is your pre-chlorination. Okay, next is your pre-chlorination. So from the name itself, pre-chlorination means, you see, pre-chlorination is the process of applying chlorine to the water before filtration, or rather before sedimentation coagulation. Okay, so that means when chlorine is added, okay, before filtration process, okay, or before filtration, or you can say before your sedimentation aided with coagulation process. Okay, so when chlorine is added before your filtration or sedimentation coagulation process, so that is known as your pre-chlorination. Okay, then you can write it helps in removing coagulation and reduces the loads on the filters. Okay, so it also reduces the taste, other algae and other organisms. So the chlorine dose should be such that about 0.1 to 0.5 milligram per liter of residual chlorine comes to the filter plant. Okay, so the normal dose is between 5 to 10 milligram per liter. Okay, then it is written that after pre-chlorination is done, it is always followed by post-chlorination so as to ensure the final safety of water. Okay, so after your pre-chlorination, always post-chlorination is done. Okay, so what is post-chlorination you see here? Post-chlorination, or sometimes simply called chlorination, is the normal standard process of applying chlorine in the end when all other treatments have been completed. So when you have done all the treatments and at the end you are adding chlorine to that water, so that is known as your post-chlorination. Clear? So while treating normal public supplies, the post-chlorination is adapted after filtration. So it is normal when you treat the normal public supplies, the post-chlorination is done after filtration and before the water enters the distribution system. That means before, after filtration and before the water is sent to the distribution system, then your post chlorination is done. Okay, then the dosage of chlorine is 0.1 to 0.2 milligram per liter. Okay, so up to post chlorination we have completed today. So later, next class, we will go to the next definitions. Clear? So today up to your post chlorination only. Okay, so I will share this PDF with you. Okay, so that you can write down in your copy. Okay, roll number one.
Yes, ma'am.
Roll number two.
Yes, ma'am.
Okay, three,
Present, ma'am.
four, five, six, seven.
Ma'am.
Okay, seven present. Eight, nine,
Present, ma'am.
10, 11,
Yes, ma'am.
okay, 12,
Present, ma'am.
13,
Yes, ma'am.
14,
Present, ma'am.
15, 16, 17, 18, 18 present. Okay, present, present. 19,
Yes, ma'am.
19 present. Okay, 20,
Yes, ma'am.
Present, ma'am.
okay, 21.
Yes, ma'am.
Okay, roll number 8 is present. Roll number 4 also present. Okay. Okay, roll number 20 present, right? 20 is present. Okay. 21,
Yes, ma'am.
21 present. 22, 22, 23.
Yes, ma'am.
Okay, 24,
Yes, ma'am.
25,
Present, ma'am.
26.
Present, ma'am.
Okay, 28. 28. 29.
Yes, ma'am.
30.
Ma'am.
30 present. 22 is present. 22. Okay. Then 32. 32. 33.
Present. 32
32
present, ma'am.
present. Okay. 33. 34.
34.
Yes, ma'am.
34 present. Okay. 35.
35.
36. 37. 38. 39. 40.
Yes, ma'am.
Okay. 41.
Present, ma'am.
Okay. 42. 43.
Yes, ma'am.
Okay. 44.
44.
Yes, ma'am.
Okay. 45.
45.
Present.
Okay. 46.
Yes, ma'am.
47.
Present, ma'am.
48. 49. 50. Okay, see the absent ones. Roll number 5, 6.